Hello, this is Andy Sullivan, Process Plant Technology Instructor at Montana State University Billings City College. Today we're going to walk you through, with the help of some students, how to conduct a D-86 distillation. We'll walk you through the procedure step by step. We have a detailed procedure right here that we're going to sign off as we go. It's based on the official ASTM method, and we'll get started. First step in our procedure is to conduct a pre-task hazard assessment. We have our form here, and what we identified as fire hazard is one of our primary concerns. And so what we're going to do to manage that is we have Tyler here is going to be our fire watch, and so we stationed a fire extinguisher that we verified is current, and we'll have an individual who's standing by the fire extinguisher ready to put out any kind of a problem. In addition to that, we have a safety shower that we've tested today to make sure that we have adequate flow of water in case we need that. It's very near our D-86 apparatus. We have a fire blanket stationed close by, and we're wearing flame retardant clothing. The next hazard we have is we're going to be conducting a D-86 distillation on gasoline, which contains benzene, and so we need to manage exposure to that. And we're going to do that with rubber gloves, and we have the hood turned on, and so that we can make sure that we're not exposing anybody to any unpleasant chemicals.
Alright, next step is to clean the condenser with a piece of lint 3 cloth. So we're just going to put this down here.
And that might be as far as you get because it has trouble turning the corner, so you might have to go from the other side. Oh, you got it in there good now. Perfect. Cool the sample, the graduated cylinder receiver, and the boiling flask to less than about 50 degrees, and we've done that in a cooler with some ice. Charge the cooling bath with ice water so that it covers the condenser. Transfer our cooled sample into our cooled graduated cylinder to the 100 milliliter mark, such that the bottom of the meniscus is even with the 100 milliliter mark. We do that from a beaker. You'll note that the sample was in a canning jar, but it spills like crazy from a canning jar, so transfer it to a beaker first. We've learned that from experience. The next step is to transfer our sample from the graduated cylinder into the boiling flask. Make note that you make sure the side arm is pointing up in the air, and we also learned that the hard way when we had the sidearm pointing down and all the sample poured out onto the floor. The next step is to add a boiling stone to prevent the sample from bumping when it starts to boil or boiling over. Position a distillation flask support board with a 38 millimeter hole on the heater, and then position the distillation flask on that support such that the sidearm fits into the condenser tube snugly. You'll want to make sure everything's nice and level and snug. That looks good. Insert a thermometer into your boiling flask such that it extends below the takeoff arm. We've measured this one out carefully. We've used a mercury thermometer in the past, but with the hazards of mercury, we just as soon use the digital thermometer. Plus, the digital thermometer makes it quite a bit easier to collect your data. Place the receiving cylinder, the graduated cylinder, in a temperature-controlled bath under the outlet of the condenser. We've added a little bit of water with some ice to control the temperatures cool, and you'll notice that we have the bottom of the outlet of the condenser positioned kind of centered in the cylinder so that we can see the first drop emerge. Okay.
Cover the graduated cylinder with the receiver cover to reduce evaporation from the top.
The finished distillation apparatus ready to go. Area free and clear of clutter and combustibles for maximum safety.
Alright, we're going to start the distillation by turning the heat up to 50%.
A stopwatch for collecting times is useful, but we'll use the time stamp on the video for our data. Distillation has been going for about 5 minutes. You can see we're starting to see some boiling around the boiling chip, and we're starting to get a little bit of material condensing on the bottom of the thermometer, which is centered in the tube. And then what we'll do is we'll watch down here at the outlet of the condenser for the first drop of material, and then we'll record the temperature. The first drop is forming, and it just dropped, and the temperature is 102, 103.9, and so that's the initial boiling point, 103.9. We're going to move the condenser, or the graduated cylinder, back so that the condenser touches the side of the condenser so that it doesn't drip into the product. And then we're going to set this camera up, or if we were doing it manually, just watch it. And we're going to watch and record the temperature at 5, 10, 20, 30, 40, all the way up to 90, 95 milliliters recovered. They're a little tough to see, and we can't position the thermometer quite right. It's a little big for this. But I'll help you with the initial one. We're getting close to the 5 milliliter mark. We read when the meniscus, the bottom of the meniscus is even with the mark, and we're real close to 5 milliliters right now. Best I can see, I'd call that. So about 119.7 is 5 milliliters. We have a splash guard on this apparatus just in case something breaks and it doesn't let it splash everywhere, but it makes it a little hard to see the bottom of the graduated cylinder. We can zoom right in and see how it fills. Call that about 8 milliliters right there, and we'll mark the temperature when we're at 10. And then for the purposes of this lab, I'll let you be the judge of the levels and the temperatures. And I'll try to keep the camera in focus as we build level. coming up on about 14 milliliters here. You can see that we're at a good roll and boil on our boiling flask here. We're still at 50% heat. You'll note in the procedure there are some constraints on how long it takes to boil material over. I find that it's very difficult to achieve that on the fly. You almost have to run it and then go back and analyze your data and then make a correction to your heat source and then run it again. The first time we ran this, we ran it with a mercury thermometer, and it takes a little bit of time to read a thermometer accurately, and this goes fast enough to where that made it a very challenging exercise. Coming up on 20 milliliters. A little easier to see now as we're getting more even with the camera and we can see over the top. I'd say we're not quite there yet, but I probably would call that 20 right there. That was surprisingly inexpensive. I forget what we paid for that apparatus. This one is the one that I mentioned. Never had a way, so that'll be. Yeah. I worry about this when we're not too far into the program because there are some hazards.
So that'd be basically kind of the same setup to sample on it.
Maybe I'll talk on the video. Now, this apparatus that we're running here is all done by hand, and so you collect the temperatures as you watch the graduated cylinder fill. In a refinery, this apparatus is common. As I recall, when I worked at a small refinery here in Billings, Montana, I think we had about 4 of these that ran all the time, and they were automated. And so there was a machine that ran along the graduated cylinder, and it had a magic eye in there, and it would move up and down, and it would kind of track that meniscus, and it would monitor the temperature in a computer, and it would record the distillation results itself. It probably modulated the temperature to meet the boil-up requirements of the method as well. And I think we had 4 of those, and I remember looking at those and watching them because they're interesting to watch, and you'd have maybe 4 of them running at one time. The apparatus that you collect the data by hand is, I think, actually more instructive. You learn more from it, but it takes a lot of personnel time to run the distillation, and so it's not really cost effective on the large scale. Things are looking good. It's been about 8 minutes since the first drop, according to the camera timer. One of the things you'll notice as we watch the distillation proceed is the material we're recovering in the graduated cylinder is crystal clear. It's water white. It really has no color to it. You can see it to the side. It's like water. Whereas the gasoline that we're starting with is the color most people expect gasoline to be, which is yellow. And this is old gasoline. This was from my lawnmower. and so it's not a stellar example of gasoline, but it's what you might typically encounter. But the colored bodies are all large molecules that don't boil over at low temperatures, and they stay back in the distillation in the boiling flask. And we'll see that even as the graduated cylinder fills up, even when we're at 98% of the gasoline boiled over, it will be crystal clear. All the color will stay in the boiling flask.
From the impurities or from your additives? Or is it just...
I don't think it's the additives. I think it's high boiling materials that would probably more properly fit in a diesel stream, but it's just a limitation of distillation in a commercial plant. To separate all those molecules out perfectly, you'd need a lot of money, a lot of cost in distillation, which would make your gasoline more expensive. But though there's such a small number of molecules there to make that yellow color, it doesn't have any ill effects on a gasoline engine, and so it's just not cost effective to remove those. We'll try to keep the distillation flask vertical, so it gives us a nice accurate reading. I think that's pretty good there. Yeah, so that'd be kind of neat. Give people the ability that can't come to lab to get at least a chance to experience it pretty good. I couldn't find much on the internet for this kind of thing. Now this distillation has taken place in Billings, Montana, which is about 3,000 feet above sea level, and so our atmospheric pressure is less than sea level, which is where the data is kind of most relevant. Everybody wants to compare gasoline to gasoline, and so you need to make some corrections. The procedure has details on how to make those corrections, and I'll post the procedure for anybody right next to the video on our faculty website. we'll need something to pump that thermometer up on. That's working out really good. Nice to have the time in there, then I could kind of double speed this thing. I'll probably have to do that anyway. But when I put it in the video, I can double speed it. Maybe I'll just put some markers in there for where the time was at each of the what is it, 13 point distillation, and then I can speed it up. I can break 4 times the speed. Save the speed. People are going to double speed it anyway when they're doing this.
Yeah.
So I might as well do it for them. Hopefully it works out. If not, I'm going to run it again on Monday with the other group, or Tuesday, the other group of second years. And then we can catch anything we missed. So that'd be kind of neat. I think it's kind of interesting again when it gets right toward the end. You can't get the last little bit out. It's hard. It starts smoking real bad. I think there were some guides on what it takes to, I can't remember, there's the final boiling point. So conditions that correct the thermometer the instant the first drop of condensate falls. The final boiling point. The maximum corrected thermometer reading obtained during the test. And what's interesting is it'll warm up and start cooling down. So we'll see how that goes. There's Start this thing back up. Just got that in time. The thermometer timed out at about the time we needed it. See that that's in the way here. I'm going to twist this just a little bit. How's that? Can we still read it pretty good? I'd say so. Still pretty vertical. It'll start to slow down when you get near the end of the distillation. We're at a little past 75 LV% off, and it's been about 21 minutes since we started. I think maybe what we'll do is we'll increase the heat up to about 60%. In the past we've had to do that around 90, but I don't see, I think we'll probably be okay if we do it now. So we're at 60% heat right now, and that'll keep this thing going without it slowing down too much on us. All the points are pretty routine, except for the initial and the final. The initial is the first drop, and you have to kind of be on your toes to catch that. And then the final is, in my experience with the samples we've been using, it just doesn't get quite to dryness. And so what'll happen is there's a little material left. It'll finally get to a temperature where it starts almost decomposing in the boiling flask, and it'll start to smoke. And you'll see the temperature spike and start coming down when it starts to crack. And so we'll watch for that temperature spike, and we'll call that the maximum temperature, our final, and then I'll move the camera and show you the smoke that it forms in the glass. We'll try to turn it down before it gets too hot because we don't want to take a chance of breaking the glass. I have this on standard definition video, which I think is fine for this. I think it'll do a high definition video too. there. When we ran this SAM sample earlier today, we got 98%, 98 milliliters out, and then it wouldn't get any hotter. I think we're getting higher temperatures than we had earlier today. I don't understand that. Past the 95% mark now. Temperature's at 397, that's reasonable for getting close to the end point of a gasoline range. You know, typically it's C5, you know, 100 degrees to 430. You can see that we have getting quite a bit less material here. It's getting almost like a thick look to it. You'll see when we get to the final, it'll get smoky in there. But we'll never boil that all off if it's like samples we've run earlier. So what we'll do is we'll just keep an eye on the temperature and the volume, and then we'll watch for kind of a maximum temperature. If it starts to crack, the temperature will take a kind of a sharp dip, and then we'll know we're at the final. Earlier today it was about 98%. We're at 416, it's starting to smoke. It looks to me like we're at about 97% off. About as close as I can see. It's a little hard to see up there with the clamp. and it's starting to cool down. Wasn't it 416? Now it's 414, 413. And so it's cooling down. You can see our flask is smoky. Another indication that the material is starting to crack. And so we've turned the heat off before we get it so hot that it breaks the glass. And then we'll let it cool.